Good evening, students. Today I am going to start a topic whose name is application of derivative. It is a very important topic for your examination, like as IIT JEE Mains, IIT JEE Advanced, and various state entrance examination and other colleges. So I hope you will feel very comfortable with us after this. You have never need to learn the basics of this concept. We will start from 0 to hero. Okay? Now suppose that in application of derivative, it is also called AOD. The short form of application of derivative is AOD, that is application of derivative. It contains 4 topics. At least actually this is contains 5 topics, but the most important topic is that the first is the very important topic, whose name is maxima and minima. Maxima and minima is the part of AOD, and the second is increasing and decreasing function, which is also called monotonic function. Okay? And the third is tangent and normal. I think in class 11 you have already studied tangent and normal, but here we have studied according to the application of derivative. And fourth is rate as measure. Rate as measure, it is also a part of application of derivative. And the fifth is approximation. The last topic, approximation, it is not as so much important as the other 4 important, because weightage of the 5th chapter is 0 in IIT JEE Mains examination and IIT JEE Advanced examination and other state engineering examination and like as and in the examination of NDA and many more. But for the purpose of board examination, this topic is also important, approximation. So now we are going to connect these 3 topics: maxima, minima, increasing, decreasing, and tangent and normal. Actually, basically these 2 topics are not separated: maxima, minima, and increasing, decreasing. The maxima, minima is a topic in the way of increasing and decreasing. While we study increasing, decreasing, the critical points, the point where the curve change their nature is called critical point. That critical point attains a fixed value, either maxima or minima. Okay? Now we are going to start some basic concept of maxima, minima, tangent, normal, and increasing, decreasing. Today I will discuss only the basic of these 3 chapters, which is most important for you. Suppose that we have a Cartesian plane x and y. I think you know very well what is Cartesian plane. The plane which consists 2 axes. One is horizontal, is called x-axis, and one is vertical, which is called y-axis. Suppose that here we have a curve like that. Okay, and you know very well a function is represented by y is equal to fx. Suppose that any function y is equal to fx, the curve is y is equal to fx. If you put the value of x, then we get the different value of y. For the particular value of x1, we get a value y is called y1, and for the particular value of x2, we get y2. And the point y1 and y2 is lies on the curve, and x1 and x2 also lies on the curve. Suppose that we have a point interval. This is called A and this is B. The whole curve is divided, described in the interval A to B. Clear? That means curve is continuous in A to B. I think you know it very well what is the continuity and what is the differentiability. I think you know. Continuity, that means there is no lags between the curves, and the differentiability, that means there is no any sharp point between that interval A and B, so that the curve is called the differentiable between interval A and B. Okay. Now we have to study that what is increasing, decreasing, and maxima and minima. Actually, increasing, decreasing, and maxima, minima are the similar term, same term. Suppose that we divide this curve in some interval, small interval, like this is C, D, okay. So we divide the interval A, B into sub-interval, just like A to C and C to D and D to B. So small interval, and all the sub-intervals are the subset of interval A and B. That means A, B are the superset of the interval C and D. It is also closed, and A and B is the subset of, superset of interval A and C, and similar D and B. So firstly we have to discuss that what is the slope of any line, what is dy by dx. So dy by dx, what is dy by dx? Okay, in class 11th we have covered a formula m is equal to y2 minus y1 upon x2 minus x1. Okay, where the y2 is fx1 and y2 is fx2 and y1 is fx1 and x2 minus x1. x1, x2 are the 2 points are on the x-axis at which the curve is defined. So we can write it y2 minus y1 is represented at delta y and x2 minus x1 is represented at delta x. Such as in previous classes, in junior classes, you have represented delta v is equal to v2 minus v1. So difference of two quantities is represented as delta. Similar, delta y is equal to y2 minus y1 and x2 minus x1. From our convenience, we can write it. Convenience is convenience for typing. We can write that we can replace delta by dy and delta x is dx. So that means dy upon dx is also the slope of any line. Dy by dx represents the slope of any line. Okay. If we see this curve from A to C, what we observe from this is a particular point K. Suppose that this is a point K. At point K, K is a point where the curve change their nature. You can see it. Before K, curve trying to increase. देख रहे हैं ना, curve trying to increase. From A to K, curve trying to increase. Curve is increasing. As the value of x increasing, we get the value of y is also increasing with respect to x. Okay. That means curve is increasing. And after the point K, the curve start decreasing. That time, as the value of x increasing, the value of y is decreasing. Suppose that here the value of x is, suppose that value of x is 1 and here the value of x is 2. So at this condition, at x is equal to 1, y is more than that comparison of when x is equal to 2. That means on increasing the x, y decreasing. This is the property of decreasing function. And on increasing the x, y is increasing. This is the property of increasing function. So between increasing and decreasing, we get a point K. K is the point where curve change their nature. Before K, curve increasing, and after K, curve decreasing. This is called critical point. We have also covered some definition in physics in class 11th and class 12th and class 10th. What is the critical temperature? What is the critical angle? The critical means that point where something changes. That is the K is the point where the curves change their nature from increasing to decreasing. That is called critical point. Okay. The point where curve change their nature, it's called critical point. And the secondly, from C to D, after K, curve start decreasing. Suppose that this is the point P. So before P, curve is starting to decrease. Curve decreases, and after P, curve start again increasing. Curve is increasing, and after this point again curve is decreasing. So there are these 3 points where curves change their nature one by one. So these are called the critical point because these are the points where curve change their nature. So what is the critical point? The points where curves change their nature is called critical point. Critical point is as important in maxima minima, and similarly it is also important in increasing and decreasing function, because that is the point where we can find that where is maxima, curve attains maxima or minima, and that is the point which converts the curve from increasing to decreasing and from decreasing to increasing, because this is the property of critical point. At the critical point, curves change their nature. So now, how can we say that for the increasing function dy by dx is less than equal greater than 0 and dy by dx is less than 0 for the decreasing function? How can we say that? So now we can check. Suppose that this is a critical point. Before critical point, there are 2 points such as x1 and x2. Clear? Their corresponding values are y1 and y2. What is the property of increasing function? According to property, the function is called increasing as the value of x increases, so value of y is also increasing. That is called the increasing function. Okay? The value of x is increasing, the value of y is also increasing. That means when x1 is less than x2, this implies fx1 is also less than fx2. That means x1 is increasing, so y is also increasing. Okay? That means if y2 is greater than y1, that means the slope m is equal to dy by dx is equal to y2 minus y1 upon x2 minus x1. Essentially, I have cleared this. What is the m? M is equal to slope of line, which we can find y2 minus y1 upon x2 minus x1. Here we see that y2 minus y1, since y2 is larger than y1 and x2 is also larger than x1. So difference of y2 and y1 is positive, and similarly x2 minus x1 is also positive. So hence we can say that dy by dx is greater than 0. Clear? So we will reach a result. That means the for increasing function, these are the properties, algebraic properties of increasing and decreasing function, and this is the property of increasing decreasing function with by the calculus. So by the differential calculus, application of derivative, we can find the function is increasing or decreasing by using this property. That is dy by dx is greater than 0. Okay. So I think there is no any doubt about it. Okay, why the dy by dx is greater than 0 for increasing function. Listen to me carefully. These are the basics for clearing all the questions for JEE Mains and Advanced. Okay. So now for the decreasing function, after the point k, which is called critical point, now we have considered 2 values. Again, suppose that x1 and x2. Suppose that. Okay. For the decreasing function, we can say that as the x increasing, their corresponding values of y, these are the x y1 and these are y2. Here like so for another curve. Okay. Suppose that these are the curve. Okay. These are the values of x. This is x1 and this is x2. We can say that value of x is increasing, x1 and x2. So we can say that x1 is less than x2, and their corresponding values on the y-axis is y1 and y2. So you can say that you can see that it is clearly, you can say y2 is is smaller than y1. Okay, y2 is smaller than y1. These are the properties of decreasing function as x1 is less than x2, but y1 is greater than y2. That means value of x increasing, but the value of y is decreasing. You can say in that term. It is possible only when the curve is decreasing. When the x is increasing, value of y is decreasing. These are the property of decreasing function. So, what is the slope? Y is equal to dy by dx is equal to y2 minus y1 upon x2 minus x1. According to our relation, the x2 minus x1 is positive because x2 is greater than x1. So, this is positive. And since y1 is larger than y2, so difference of a smaller and larger value, y2 and y1 is negative because y2 is smaller than y1, so negative. So we can say that here dy by dx is less than 0. Okay. So now we get another result. For the increasing function, dy by dx is greater than 0. And similarly, for decreasing function, dy by dx is less than 0. Okay, got it? Now we will discuss what is the property of maxima and minima, and why for the maxima or minima dy by dx is equal to 0. The function attains maxima or minima, it will clear after the second order derivative, after some discussion. Okay. So, why at the maximum minima dy by dx is equal to 0? Firstly, we can say that maxima or minima, any curve between any interval attains maxima or minima at the critical point. You can see that there. See, the before this point curve is increasing, and after reaching this point curve start decreasing. So these are the maximum point between A and here this point C. And again from here curve start decreasing. That from this point, before this point curve is decreasing continuously, and after that point curve start increasing. So as we discussed, the critical points are the points where the curves change their nature. So we can also see that at this critical point function attains a value which is maximum or minimum as comparison to their neighborhood point. If we see that here at this point the value of curve is maximum at their neighborhood point. We cannot say that the curve is absolute maxima here. There are two types of maxima or minima. One is called local maxima and local minima, and another is absolute maxima and absolute minima. Such as this value is the maximum as comparison to this and this point. But if we see, we count a whole curve from A to B, we see that these are the absolute maxima because no any point has maximum value, has value more than it. So these are the highest. So this is called absolute maxima, and the lowest value, the point at which the lowest point where the value at lowest point is called absolute minimum. So if we, here we have 3 points, these all are critical points. If we draw a tangent as these points, we can say that if you draw a tangent, suppose that we draw a tangent at this point because this is the critical point. Okay, here and here and here. We can say that all these tangents are parallel to x-axis. So if you draw any tangent at the critical point, so the tangent will be parallel to the x-axis. That means the tangent makes an angle 0 degree with the x-axis. Okay, these all tangents are make 0 degree angle with the x-axis. So the slope of tangent, which will be represented by dy by dx. Recently we have discussed what is dy by dx, and slope is also denoted by dy by dx is equal to tan theta. V is equal to, here theta is 0 because all the lines, all the tangents are parallel to x-axis, then the angle of the lines with the x-axis is 0 degree. So tan 0, the value of tan 0 is 0. So we will reach a result, at the result dy by dx is equal to 0. Now we can say that it is clear that for the maximum or minimum, why we say again and again maximum and minimum? Because at the critical point we have only two values, either maxima or minima. Either maxima or minima. So at the critical points, the first derivative of any function dy by dx is equal to 0. Yeah, I can say that at the critical point, the first order derivative as the slope of line is equal to 0. Okay. We can prove it by another method. The slope is represented by dy by dx is equal to y2 minus y1 upon x2 minus x1. If any line is parallel to x-axis, that means for the line parallel to x-axis, y is equal to c. That means the value of y is constant. That means the value for that function y2 is equal to y1 is equal to y3. All the values are similar, which is equal to y. Suppose that. So the difference between two similar values is always equal to 0. So we get dy by dx is equal to 0 upon something delta x, which is also equal to 0. Okay. So it is clear that I think you can understand it very well that why the dy by dx is 0 for the maxima or minimum. So dy by dx is equal to 0 for the maxima and minima. Why you can say. Okay. And how can we judge at that point, particular critical point, the function attains maximum or minimum? It is clear from here that at the critical point, function attains either maximum or minimum. Okay, got it? But sometimes it is not true. A critical point is a point where curve changes their nature, not a point where curve attains maxima or minimum. Yes, it is true that at the critical point, curve attains maxima and minima. If any points curve attains maxima or minima, then surely that is the critical point. But at critical points, curve attains maxima or minima. It is not true. Sometimes a point is a critical point where the curve is not differentiable. For example, the mod of x. Here x is equal to 0. Before x is equal to 0, these curves decreasing continuously. And after x is equal to 0, curves start increasing. That means this is the point where curve change their nature. So this is the critical point for this curve y is equal to mod x. But at this point, function is not differentiable. Okay. So it is also an important that at critical point, this is not need to be true that function is differentiable. There are some critical points at which function is not differentiable. That means if x is equal to a is a point where function is not differentiable, that means that is the critical point. Okay. And the second topic is that at critical point dy by dx is equal to 0. So if we have an equation dy by dx is equal to something, so on equating it is equal to 0, we can find the critical point. Okay, got it? The equation dy by dx is equal to 0 gives us the value of x, that is called the critical point. Okay. So now how can we judge that at this point function is increasing or decreasing. Okay. These are also important. To check that at any point function is decreasing or increasing, there are two methods. The one is use of first order derivative and the second is the use of second order derivative. Now we will discuss the use of, by using the first order derivative, how can we judge the at that point function is at particular critical point function is increasing or decreasing. Okay. Suppose that this is the point K and these are some critical point K, M, N, whatever. So suppose here according to the graph, we can say that this is the maximum point. That means at this critical point, the value of fx is maximum. Function attains maximum here. Okay. Take it. After reaching the maximum point, function start to decrease. After this point, function start to decreasing, and before this point, regularly function are trying to increase. Okay. So for the increasing, recently we have discussed for the increasing function dy by dx is greater than 0. Okay, got it. And for the decreasing function dy by dx is less than 0. That means before these points, the first order derivative of function change their sign. Okay, change their sign. Before this point, suppose that these are the critical point. Before this critical point, the dy by dx is positive, and after that point, dy by dx becomes negative. So firstly we need to find the critical points of a function. Then we have to discuss that if at that point the function becomes negative from positive, then it is clear that at that point function attains the maximum value. Okay. And we can also see that these are the minima points. These are the critical points at which function attains the minimum. So before these point, function are regularly decreasing. That means dy by dx is less than 0. And after this point, function again is starting to increase. That means dy by dx is greater than 0. That means if suppose that these are the second critical point too. Before that point, nature of dy by dx is negative, and after that point, the dy by dx becomes positive. So if in any case dy by dx turns from negative to positive, that means these are the minimum. At that point, the function attains minimum. This is not minimum. At this point, the function attains minimum. Got it? These are the basic properties of maxima and minima. And one more thing, as we discussed that at the critical point, if function attains the maxima, that means at this point function has a value greater than these their neighborhood points. These neighborhood points. Okay. Suppose that at any function, this is any function at which x is equal to a, is the critical point. That means all the points before a, the value of function is a minus, f of a minus, and after that f of a plus, all are less than fa. So if fx attains a maximum value at a, then we can say that fa is greater than fa positive and f a is also greater than f of a negative. Okay, got it? So, and what is the method of justify the maximum or minimum by using the second order derivative? So we know that for the by using the second order derivative we can also find at which at which point the function attains maxima or at which critical point function attains minimum. Okay, if the second order derivative at any point, at any critical point is greater than 0, then we can say that the function is attains minimum. How can we say that? While d2y by dx2 is greater than 0 at the minimum point. So before understanding it, we have to understand the concept of concave up and concave down. Okay, so we will start what is concave up and concave down. Listen, there are two things. That suppose that this is a curve and you can say that this is convex up and concave down. Clear? Both are similar, convex up or concave down. Similarly, at this curve we can say that concave up and convex down. Okay, so